Hi there, class. Let's review problems 5 and 6 in our learning packet on energy. Problem 5 states, a 1.6 gram sample of a metal requires 1.6 calories of energy to change its temperature from 23 degrees Celsius to 41 degrees Celsius. What is the specific heat of the metal? Okay, so we're going to call our boy Eric P. over to do some of these problems for us. Oops, I lost track of my space. Got a little excited about Eric P. coming. Okay, so we're dealing with the energy units. We know that our equation is E equals mc delta T. Delta means change, or change in temperature. So we wrote out the equation. We're good there. We need to rearrange it. Let's rearrange that equation. Well, they are asking us for the specific heat, and the specific heat is C. So to rearrange for C, we are going to divide both sides by m delta T. Thus, C equals E over m delta T. If you need help with this part right here, we can do this when I get back. This is a little bit of algebraic manipulation. If this was easy for you, you should be fine with the math and physics next year. I will walk you through that when we get back. Okay, let's crisscross. In order to solve for C, I need E, I need M, and I need delta T. Let's walk through it. E was given here, 1.6 calories. If you remember correctly from your notes, energy should always be in units of joules. So we need to do a simple crisscross here, and we need to convert that to joules. We're going to use our conversion factor that states 1 calorie is equal to 4.184 joules to do this conversion. Since it's up top, we're going to times. So we are going to take 1.6 and we are going to multiply that by 4.184, and we are going to get about 6.7 joules. All right. That's great. Our mass was given here as 1.6 grams. We do want the mass in grams, so that's fine. We do not have to crisscross there, and we're never going to have to crisscross with temperature. Let's set it up though. It's going to be the final temperature of 41 degrees Celsius minus the initial temperature of 23 degrees Celsius. 41 minus 23. Well, 40 minus 23 is 17, so it should be 18. Let's double check. Yes, it is 18. There's your delta T. Again, this thing you're doing right here is what delta means in science. It means change. So we need to plug. If the tongue wags, that's not where we want to be. Where are you? There you are. Be careful here. Be careful, mister. Okay, so we need to plug. We're going to plug into our equation up above. I just dropped my book on the ground. Sorry about that. So we're going to plug into this equation. C equals E over m delta T. E, 6.7 joules, M, 1.6 grams, and delta T, 18 degrees Celsius. Notice nothing cancels, but we end up with the units we want. Joules per gram, degrees Celsius. So, I'm going to multiply 18 by 1.6, 18 times 1.6. That's going to be 28.8, so we're going to take 6.7 divided by 12. 6.7 divided by 28.8, that equals 0.23. So 0.23 joules per gram degree Celsius, and we're going to find out later that that's the specific heat of silver. Transition metal silver really isn't that hard to heat silver up as compared to water. Cryo is only 0.23 joules to raise it 1 gram every 1 degree Celsius. Let's move on to problem 6. A 2.8 gram sample of the metal requires 10.1 joules of energy to change its temperature from 21 degrees Celsius to 36 degrees Celsius. What is the specific heat of the metal? Okay, they're asking me again for specific heat, but we know that there is this equation, E equals mc delta T, change in T. We need to rearrange this question to solve for this equation to solve for specific heat. That's going to be C again. From the last problem, we knew that E equals m over delta T. So we're going to set up our crisscross. We need to solve for E. They give us 10.1 joules. We are good. This is good. We want joules. M, 2.8 grams. Perfect. We want grams as well. Delta T, and we're home free. 36 minus 21 degrees Celsius. I believe that's 15, of course, but I'm going to get on my little ghetto superstar, and I'm going to do it anyway. 15 degrees Celsius. So I didn't have to do any crisscross here. This is going to be an easy problem. Literally, plug it into the equation. We're going to chug out the answer. C equals E over m delta T, which equals 10.1 joules over 2.8 grams multiplied by 15 degrees Celsius. We again end up with our units of joules over gram degree Celsius. 2.8 times 15, 15 times 2.8, 42, so 10.1 divided by 42 equals 0.24 joules per gram degree Celsius. There is the answer. We are set. After listening to this video, if you guys have any extra time, I encourage you to go on and try problems 7 and 8. Again, I want to do a quick review over this. We set up the problem, our major equation. We rearranged the equation to solve for specific heat. We listed out the variables we were solving for, that being energy, mass, and delta T. We crisscrossed energy to make it joules. Mass was already in grams, and we found the change in temperature, and we plugged into our problem, our equation, to get the answer. To review the one we just did. Again, our major equation was E equals mc delta T. We rearranged the equation for C. We listed out our variables, and we did not need to convert or crisscross. The reason we did not have to crisscross was it was already in joules. It was already in grams. Delta T is never crisscrossed. We plugged in and we got our answer. Yay! Alright, I'll see you guys on Monday. Take care.